Of this installment of looking for compounds that pharmacologically might behave like ketamine. When we left off last time, we downloaded a ligand library from the Zinc 22 database. We went through how to use command lines to do that. After that is all done and you have a downloaded file, remember that we created a file folder for that, and the file that I gave the name was NMDA ketamine. Okay, NMDA receptor is what that means, and then ketamine is the name of the compound. So I'm going to click on that file folder, and as you'll see in that file folder, I now have three subfolders, H16, 17, and 18, which were the tranches that we downloaded from the Zinc 22 carte blanche database. And we also have the file installer in here. We don't need the file installer anymore. You can delete that in subsequent files if you want to save hard drive space. Click each folder. You can click each folder. You should be able to right click and there should be an extract button. These are zip files. If you kind of look at each file folder here, it's a TGZ, so you'd have to extract each file folder. Okay, you can to do this, you can highlight. You can use Control A, Command, get rid of that. Get rid of H16. You can right click it. You can go to extract here. It'll extract all of the TGZ file folders, and then from there, if you now were to search within one of those, I've already done the extraction, so if you need to do the extraction, do it. It'll pull all the files out of each folder. If you then, in the search bar over here, search for each molecule, they're going to be under .stf files, so I'm going to type .stf. It's going to take a while to go through all this process because it's looking for each one of those files. Maestro workspace. Okay, the search bar went away, which means everything is done. I'm going to go to Control A to select everything. I'm going to go to Command to get rid of these TGZ files. If you drag them into Maestro, nothing bad will happen. It'll just say failed, only on the TGZ files, but it will drag in the SDF files. So I'm just doing this to be tedious because it's what I like and prefer to do. I'm going to click the window to minimize a little bit, open up the project file. Okay, and then I'm going to basically click and drag. Okay, now it should work. It's a click, hold, drag, and then drop. All right, wait. And without anything popping up yet, you kind of know what's working is if you hold your cursor over anything, notice how it doesn't change. There it goes. Okay. There it goes. And see, it's importing all the files into the folder. You have to make sure you do this for those other two folders. I think it was F16 and F17. You can check on that though. I'm not going to show that in this video because it's the same process, but make sure you do it for H17 and 18. Same thing. What I'll say here before this finishes up is this is actually the part of the screening process that eats a lot of RAM. If I go to Task Manager, you kind of see that as you're loading molecules in, your working RAM will slowly go up. The only reason mine doesn't go up very much is because notice how I have a 135 gigabytes of RAM available. This is a maxed out DDR4 system, which is 128. But this is what eats RAM, loading in these molecules. Okay, finished. Great. Loaded all the molecules in, which this looks fantastic. One of the ways to save RAM space is if you go to, every time you load molecules in, if you go to File, Save Project As, and if you give the file a name, let's just say it's NMDA ketamine compounds. If I save that file, if I close this, go to quit. If you look at your RAM now, your working RAM should be down a few percent. Open up another terminal. Oops. /maestro. Click the project, click the project table after you reopen the file. I'm gonna go to table. I'm gonna go to right click. I'm going to go to group. I'm gonna call this ketamine batch 1 underscore batch underscore 1. It'll conveniently group all those file folders like this. You'll drag the next batch in, which is H17 and then H18. So you should have batch 1, batch 2, batch 3. When that's done, it'll look something like this. Batch 1, batch 2, and batch 3 is what it'll look like. The next thing to do is most workflows will recommend that you prepare the ligands, which means you put the ligands at the correct protonation states. Theoretically, from zinc, these are at the correct protonation state, but sometimes you have missing, let's say like a lot of times you have a missing pair of valence electrons around an atom, and that usually comes up as an atom typing error in Maestro. Maestro does fix it if you go straight to docking, but it's actually better to prepare the ligands in my opinion. So I'm going to go to lig prep, file, select the project table with the 63,866 ligands. Make sure you have the project table selected. For the pH, you can use 7.00 plus or minus 2.0. I like to use the pH of roughly blood, 7.4, and I usually like to do the plus or minus 0.5. So that's going to give you, the protonation state between 6.9 and 7.4 minus 0.5, 6.9, and then 7.4 plus 0.5, 7.9. So between 6.9 and 7.9. The name of the job for lig prep, I'm going to call this lig prep ketamine batch 1. And I'm going to run the job. Oh, make sure also when you go to the gear icon to run it, hit append new entries as a group. That means it'll auto-populate inside of Maestro as a new group. So I'm going to go to OK, and I'm going to run this job. Make sure it's running. Go to the status bar up here. Go to monitor. Double click it. It'll show you all the ligands that are running. So it's gotten through already 17 ligands, but it does have to get through 60,000. Okay, the job is completed. I've gone to the file folder, like prep ketamine 1 output file to grab that file. Should load in the workspace pretty quick. Okay, here's the file. And what you'll notice is that the original file had 63,000 ligands. Notice how my output file has 73,000 ligands. And you might be asking, why do you have 10,000 extra ligands? If you have multiple protonation states, or you have, let's say, a compound within an enantiomer, an RRS configuration, and it's not defined in the SDF file, it'll give you both the R and the S. So a lot of times you'll end up with two different enantiomers of the same compound. So you'll basically always end up with more than you started with, which is fine. Which means it will dock both enantiomers. Prep. The last thing that I want to run before I do a docking simulation, actually run the docking job, is a quick prop. Quick prop in Maestro tells you a bunch of pharmacokinetic and pharmacodynamic, mostly pharmacokinetic parameters of the molecule. It tells you things like Lipinski's rule of 5. It'll tell you things like oral absorption. It'll tell you things like the Herg value. It has a lot of really neat computations in there and calculations. So I'm going to go here and make sure you have the ligands selected from the output file of the original, which is the lig prep. I'm going to go to quick prop. Okay. Name the file. This is quick prop ketamine NMDA 1. Project file, project table selected, hit run. Right, once again to make sure it's running. This is the quick prop file that we want to be running. Make sure it says quick prop running, and it's running through all the quick prop parameters. One thing I should also mention is that by default, whenever files get run, they always get saved in the Schrodinger Maestro directory. But you can change that directory if you go here, file, change working directory. For me, I have it set up so that all of my file folders that are run get saved into this folder, Schrodinger 2024-1, but you can always change that by going to choose if you want to change that to a home directory or something. But I like this is my custom directory that I use to save all my file folders. So if I want to find that file that just ran, quick prop. What was it called? Ketamine 1 quick prop. Okay, so ketamine 1. Okay, there it is. It's always the output file that you're going to drag in. That'll be the second output file. Second one's done. Third output file. Good. All three output files are in there. Right, and obviously I think it's important to say that you're, depending on what CPU, it's actually not really, you don't need a nice graphics card for this. Quick prop jobs that have been run. Okay, I don't need the link prep. I don't need the batch files, but I'll go through each one. So the quick prop, as we talked about, has all the quick prop parameters of the compounds. Okay, and if you want to look at those, we don't need those yet. We don't need these yet. We do eventually need these when we kind of select our compounds. CNS tells you the likelihood of the compound getting past into the central nervous system. If it's CNS negative, it usually is a drug that's going to stay inside the body. If it's CNS positive, it's usually going to go into the brain. But being that we kind of picked compounds from carte blanche, like 22 that have blood-brain barrier coefficients in line with ketamine, a lot of these compounds should be CNS positive, and they are. Right, there's a few zeros, but for the most part, we have positive values. And these have things like molecular weights too. These compounds are all going to be roughly the size of ketamine. Oral absorption, Herg, these are all fairly low on the Herg scale. Molecular weights, these are all roughly compounds that are in line with the molecular weight of ketamine. Okay, setting up the actual docking screens. So I've got 3 files to get running. So I'll start with the first one. I'm going to go to Tools. I'm going to go to Ligand Docking. Oh, okay, something's incorporating. That's fine. I don't need that right now, though. Okay, make sure you select the files. I'm going to run these one at a time. I'm going to go to Ligand, Ligand, docking. We do also have to run a control file, but I'm not going to run those yet. Use ligands from project table. Receptor grid. This is going to be the ketamine grid file that we created in the last video. It's the .zip file right here. Okay, that was the 10 by 10 by 10 grid. Settings. This is a smaller screen. If I'm running a screen this is only 200,000 molecules roughly, this is pretty small. Being that this is a smaller screen, there's 3 levels of precision for docking: HTVS, SP, and XP. As you go down the list, they get more computationally expensive, meaning they take a longer period of time because they run longer samplings inside the binding pocket. Normally, what I'd recommend for you guys is run HTVS. Okay, I normally run HTVS when my screens are very large. This is a smaller screen. I'm going to run SP. If I'm running a screen that's under 1 million molecules personally for my machines, I'm going to go for SP. If I'm running more than, let's say, 1 million, I'll use HTVS. For this screen, I'm going to go SP because it's a lot smaller. Ligands, make sure you select the project table. SP, glide dock SP, I'm going to call this ketamine _1 NMDA. Okay, run the screen, run the job. Okay, the gear icon went away, the run came back up, which means the next one can get running. Quick prop 2, click it. Do the same thing, ligand docking. Everything's already selected. It'll change from a 1 to a 2 automatically. Hit run. That's our second job. Second job's running. Table, click pop 3. Back to ligand docking, run. All 3 jobs are running. Okay. Okay, so I've got all 3 jobs right here. 1, 2, 3. I can figure out when these jobs are done using some basic math. If I go to details, you'll see that this job started running on 12, looks like 12/29. Okay, 12/29, December 29th at 8:32 in, I can't tell if that's AM or P, that's probably AM. Okay, but if I look at that job, 18 sub-jobs have completed. It has to run through 51 sub-jobs. Okay, so it's roughly 1/3 done. That's been slightly over a day, 12/29, 8:32. Slightly over a day, so it'll take roughly 3 days to complete. Okay, and that's where I'm going to end this video. We'll reconvene after this job finishes in roughly 2 more days. Till then, see you next time when we actually look at the docking poses, which is exciting.